In this video, I will talk about the electric field and magnetic fields, electric forces and magnetic forces, and I will show you how we can use the concept of field in both electricity and magnetism, but just for point charges. So in this classical field theory of electricity and magnetism, we say we have the source charges, and those charges are the ones that create the field. So from these we get the field, whether it is the electric field or the magnetic field. I'm not specifying it for now. And then we know that it's the field, the one that is interacting with other charges and it's exerting a force. Now, for electricity, we know that a source charge can create an electric field by, if we use Coulomb's law, we will have 1 over 4 pi epsilon naught, and then we have the source charge r squared times r hat. Now I want to remind you, when you see r, this means this is the relative position vector of the observation minus the source. And of course from that you can find the magnitude and r hat. Now for magnetism, for magnetic fields, we have the magnetic field is mu naught over 4 pi q v cross r hat divided by the magnitude squared. Now this is something important. Okay, this is the electric field, this is the magnetic field. Both of these, okay, if you take a look at this picture, both of these are created by the source charges. Because it is the source charges, the ones that create the electric field and the magnetic field. Now this is important. This is the source charge, okay? When you see Q in the electric field, this Q refers to the source charge. When you see Q here for calculating the magnetic field from a single moving charge, this is your source charge. This velocity vector, this needs to be the velocity vector of the source charge. Okay, frequently confused. When you see a Q in equation, it is... students are often confused which Q is it. Okay, the fields are created by the source charges. Everything that you have in the expressions for electric field and magnetic field, they need to be about the source charges. Now, moving on. Now we have the force. Okay, the field can interact with other charges and exert a force on them. We know that the electric force is Q times E. Okay, when you see this expression, remember, we have used everything we know about the source charges to find the electric field. Once you find the electric field, you can forget about the source charges entirely and use that electric field and the charge that you have at the observation location to find the electric force acting on that charge. Okay, this Q and this Q, they are not the same thing. It's the source charge that creates the electric field, and this is the charge that is at the observation location. And it's the electric field created by the source charge that is interacting with the Q at the observation location. Okay, at the end of the day, this Q and that Q, they are not the same thing. And you need to know, you need to understand how the classical field theory of E&M works in order to be able to distinguish, to understand, to know which Q you need to use every time. Now, for the magnetic force, we have, again, from a single moving charge, Q, V, cross B. Now, in magnetism, things get more complicated because in electricity, we had the charge at the source location, we had the charge at the observation location. That was it. Well, now in magnetism, because things depend on the velocity of charges, unfortunately for you, we also have velocities. So this is the charge, this is the source charge, this is the velocity of the source charge, this is the charge at the observation location, this is the velocity of the charge at the observation location. So again, similarly as I said before, once you use the information about the charge that creates the magnetic field here, and you get B, everything about the source charge is included in what you see here as the magnetic field. Everything else, like the charge Q and the velocity, these refer to the charge that is at the observation location, and the magnetic force will be acting on this charge Q. Alright, so this is more or less a summary of the electric force and the electric field, and magnetic force and magnetic field for single charges. Be aware of what Q is in each equation and what velocity is.